Hi, this is Hassan Korani. Well, this is the final recording about the scalar product in a plane for grade 10. We are going to learn the application of cosine law, and we are going to see some important and useful methods to calculate scalar product. Okay. Cosine law or Al-Kashi theorem. This is very important theorem in geometry, trigonometry. The aim of this theorem is to calculate a side of any triangle, knowing the length of the other two sides and the angle between them. How? Let's see this. This is a triangle ABC. This is any triangle, as we have said, and we are going to use cosine law to calculate, let's say, the side BC, which is A, symbolized by A, and we are given we should have the length of AB and AC and also the geometric angle between them. Once you know these three factors, three parts, we can find the third part, A, in order to get A. How? Cosine law says, if we are given, this is the given as you see, by cosine law says BC square equal square of AB plus square of AC minus 2AB dot AC. Okay, this is a rule, and it has another form by changing or writing this in using definition, a geometric definition, which is BC square, again AB square plus AC square minus 2 multiplied by this scalar. Again, let me remind you that AB dot AC is a scalar, not a vector. It is 2, it will be 2 times AB times AC times cosine the angle, geometric angle between the vectors AB and AC. AB and AC, the geometric angle between them is this one, whose vertex is A. We can name it BAC or CAB, or simply, if we have no joining here, we can say it is cosine A, just A, letter A with angle A. This is the form, or simply using these symbols, we can write it in this form. A square, it will be C square plus B square minus 2C times B times cosine of angle BAC. This is cosine law. You have to memorize all these three forms, or just this and that, and these are symbols for calculation. Knowing these AB and AC, the value of AB and AC and the cosine or the angle, so the cosine of the angle, we can calculate BC square, which is unknown for us in this case. After that, as you know, BC square, it will be a number, and positive number sure, then this BC can be calculated easily. Let's see a direct example on it. Consider a triangle ABC where AB equal 4 and AC equal 2. Let's consider this drawing. And BAC, suppose that it's 60 degrees and these are whatever. Never mind. It's important to know that we can apply cosine law in any triangle, either in special triangles. And we are asked to calculate BC. So try to do it yourself before you see the rest of this video or the answer. The solution will be BC square, AB square plus AC equals BAB square plus AC square minus 2AB times AC times cosine, which will be AB square, which is 4 square, 16 plus 2 square, which is 4, minus 2 times AB 4 times 2, which is AC, times cosine of angle BAC, which is given 60. And as you know, cosine 60 is half, and 2 will be cancelled with half, and we get at the end 20 minus 8, which is 12. Thus BC square equal 12, and then BC equal square root of 12, which is 2 radical 3. As you see, this is a very good very good theorem to calculate a side knowing two sides and the angle between them. For example, if we are given, let's say, if you are asked to calculate B, you must think about a way that we should have the length of this side and that side and the angle between them to get B. And similarly, if we are asked about C, this is a way, and you have to memorize it very well. At the end, we have some useful and important methods to calculate scalar products as an application. Consider in the adjacent figure this rectangle ABCD with length AB 4 units and AD equal 3 units, and you are asked to calculate AB.AC, AB vector dot AC vector. This is the only given for us. Think about a way to calculate AB.AC. In fact, we are going to see three different methods. The first method is directly from geometric definition. Probably you are asking about, in geometric definition, we need the length of AB, and it is given. The length of AC, we can easily find it. How? Think about it. AB, we have AB equal 4 units, AC equal 3 units, and this is a rectangle, so this is a right triangle. So the diagonal will be, using Pythagoras theorem, can be calculated easily. But how could we find the geometric angle? It's not known. As you know, in a rectangle, this is not a angular bisector. This is 90, but we don't have the measures of these two angles, adjacent angles. So let's see the solution. AB.AC, directly from definition, AB, geometric definition, times AC times cosine BAC. Be careful about choosing the letters for the angle. It's AB.AC. They have the same origin as we saw in the first video. The geometric angle will be this angle, or BAC. AB times AC. Although we don't have the angle, but we can use, as you know from also from grade 9, we can use the trigonometric ratio, one of the trigonometric ratio, which is cosine BAC, cosine angle equal adjacent over what? Over hypotenuse. Cosine of this angle, it will be adjacent side, which is AB, over what? AC, which is the hypotenuse, to get. By this way, we calculate the geometric angle. We can cancel AC and AC, and we get AB square equals 16. Although we don't have the geometric angle, we can do it by this way. Okay, this is the first method. Second method, which is very important method, which we call it decomposition. And as you know, decomposing a vector means writing a vector as a sum of two vectors or three vectors or whatever. Let's see how to use decomposition to calculate the scalar product. AB.AC, it will be AB. This is a horizontal one. Well, in this case, it's good to look at the vectors in the figure. AB.AC, we have a horizontal vector and an oblique vector, like this. Usually in decomposition, it's good to think about decomposing the oblique vector, not the horizontal vector. How? We have AC. Try to write AC as a sum of horizontal vector plus vertical vector. To go from A to C, you can go in two ways. Either AB plus BC, as you know, by Chasel's rule. This is it. AB.AC, it's AB into, don't miss these parentheses. AC, we replace it by AB plus BC. AC, it's AB plus BC. Or you may write it AD plus BC. You will get the same result. Now, as a property, distributive property that we took before, AB.AB, it will be AB square plus here AB dot BC. Now look at AB dot BC. Look at AB and BC from the figure. As you see, these two vectors are what? AB and BC. The geometric angle between them is 90, thus they are orthogonal. And the dot product of orthogonal vectors is 0, which is a fact. So AB square, which is the length of AB square, this is also a particular case, which is 4 square 16 directly plus 0, which is 16, the same result as previous method. The third method is analytic definition. Now, analytic definition, we apply analytic definition in case of coordinates. Well, in fact, we don't have coordinates here, so we have to, and sometimes it is good if we are asked to do this. It's good to introduce an orthonormal system with a certain origin. If we consider the orthonormal system A 1 over 4 AB, which is 1 over 4 AB that represents the reference vector of the x-axis, and 1 over 3 AC, sorry, AD, it must be AD, this is a mistake here, AD, 1 over 3 AD, to get the coordinates of AB, the coordinates of these points A, B, C, D. After that you can find the coordinates of AB and AC. Then you can apply the analytic definition, which is AB dot AC, to get xx prime plus y prime, which is 16, plus 0, which is 16, to get the same result as previous methods. This is it, and this is our homework about what we have said now about cosine law and the useful methods. Thank you for watching, and see you in the next chapter, which is about the straight lines in a plane. Thank you.